So true misery lies in adding and subtracting rational expressions. Because in order to add or subtract fractions, we have to have a common denominator. Now, finding a common denominator when it's just numbers that we're dealing with isn't terrible. When it comes to adding and subtracting these rational expressions, when variables are involved, then the misery is real. So in the first case, it's pretty straightforward. Not too much work has to go into preparing it all. I'm just going to rewrite it so we have a little bit more room. And now we just have to find what number both 5 and 3 divide into evenly. So hopefully we can recognize that as being 15. So for the numerical part, for the 5 and for the 3, we're going to need to multiply this first fraction by 3 on the top and bottom. We have to multiply the second fraction by 5 on the top and bottom. So that's going to get us the numerical part to be common of 15. But in addition to that, we have to make sure that we have the same exponents for the y's and for the z's. And so as I look at the two denominators for the y squared and the y, that means our common denominator is going to involve y squared. We don't need any more y's than we already have in the first fraction, but we do need an additional y here in the second fraction. And in a similar fashion, if we look at the z's, I've got z squared in the denominator of the first fraction, just z in the denominator of the second. So I'm going to have to multiply by an additional z here in the first fraction. So that makes our common denominator 15 y squared z squared. And then in the numerator, we just have to multiply here, and those two separate products will be connected by addition. So 3z times 2x gives us 6xz plus, and now 7 times 5y is 35y. And so this is as good as it's going to get. We don't have any number that divides evenly into all three parts of the problem. So although like maybe we might be tempted by the 15 and the 35, remember that 35y is connected by addition to the 6xz, so we can't just cross cancel the 15 and the 35. We'd have to have something in common in all three parts. And the same is true for our variables. So this is as good as it gets. For the second and third examples, we're going to have to factor those denominators before we can really find the common denominator. So that's what we're going to do here. So for this first denominator, I can see that I can't undistribute anything, so I'm going to just kind of slide down here a little bit. And so I'm going to factor this into factor it into two sets of parentheses. Hopefully we can see that it's x and x. We're multiplying to make a positive 6 and adding to make a positive 5x, so that means it's got to be two positive numbers. And so our only options are 6 and 1 or 3 and 2. 3 and 2 is the only way that we're going to make that 5x in the middle, so we've got the first denominator factored. And now we're going to have to do the same thing for the second denominator. So I'm going to have the 2 here, and now I need to factor this guy. So again, there's no common factor in all three parts, so I can't undistribute. I'm going to go straight to the two sets of parentheses, x and x. Again, everything's positive in the problem, so it's going to be two positives. And then our options for 4 are either 2 and 2 or 4 and 1, but we have to make that 4x in the middle, so it's got to be x plus 2 times x plus 2. And so once we have those denominators factored, now we need to try to find what is that common denominator going to be. And so I look at the two denominators. They both have an x plus 2 in them, but the second denominator has an extra x plus 2. So that means I'm going to have to multiply this first fraction by that extra x plus 2, so that we've got two x plus 2's in there. And then the second fraction is missing the x plus 3 that the first fraction has. So I'm going to have to multiply this one by x plus 3 on the top and bottom. So let's go ahead and combine these into a single fraction now. So over here, when we multiply in this numerator, we're going to have x plus 2 times 1, which is just x plus 2. It's in this second numerator that we have to be extremely careful. We're not just distributing a 2 into that x plus 3. But because this is negative, I'm going to be distributing a negative 2 into that x plus 3. And so when we do that, negative 2 times x is negative 2x, and then negative 2 times 3 gives us negative 6. Or if we want to back up a little bit, it might have been easier if we would have had it as to see as minus 2 times x plus 3, and then for sure we would see that we'd be distributing a negative 2 into that set of parentheses. So I'll go ahead and go back to the result. Like I said, it's going to be minus 2x and minus 6 in the numerator. And then the denominator is just all three pieces here. So we've got the x plus 3, and then we've got 2x plus 2's. So I'm just going to go ahead and write it as x plus 2 squared. Be a little lazy about my writing. So now I just have to gather like terms in the numerator. So we've got x, we've got negative 2x, so those combine to make negative x, and then I've got 2 minus 6, so 2 minus 6 gives me negative 4. And then in the denominator we still have the same thing, x plus 3 times x plus 2 squared. And you'll notice that I haven't FOILed out the denominator. That's not necessary. We can just go ahead and leave that as is. It's just the numerator where we have to distribute and gather like terms and see how much we can simplify, do everything that we can, because then we can tell whether or not there might be some reducing that we can do. For the last example, we're going to have to do the same sort of thing, where we're going to have to factor each of these denominators and then check to see where we have some overlap. So I'm going to squeeze it in right below. I can factor out a 2 out of this first denominator, and then I'm left with x minus 6. So we can go ahead and cross that out. And then the second denominator, no undistributing is possible, so it's going to break up into two sets of parentheses, x, and then I'm going to have a plus and minus since I'm multiplying to make a negative 12, but adding to make a negative 4 in the middle. So my factor pairs for 12 are 3 and 4, 6 and 2, 12 and 1. And so now I look at that and I have to find which ones have a difference, since they're going to be one positive, one negative of 4. And so it's going to be that 6 and 2. I need to have a negative 4x win out, so it's going to be minus 6 and plus 2. So now I look at these two denominators, and it's kind of the same circumstance that we had before, where we've got some overlap between the two. We've got the x minus 6's, but the first denominator has 2 in it that the second denominator doesn't have, and the second denominator has x plus 2 in it that the first denominator doesn't have. So it's going to require me to multiply this first fraction by x plus 2 on the top and bottom, and then I'm going to have to multiply by 2 on the top and bottom of the 2 on the second fraction. So I'm going to kind of make my way down here. So we'll kind of keep the steps separate here a little bit. So we've got x plus 2 times 5, so I won't distribute that quite yet. And then on the other side I've got minus 20 times 2 gives me 40. Go ahead and multiply that out. Then again, in the denominator, no need to FOIL it, just 2 times x plus 2 times x minus 6. So now we have a little distributive property to take care of here. So 5 times x is 5x, 5 times 2 is 10, minus 40. Oh, let's try that again. Minus 40 all over 2 times x plus 2 times x minus 6. Now, if we gather like terms up in the top, we're going to end up with 5x plus 10 minus 40 is minus 30 over, again, that same denominator. Now, hopefully, we're seeing that we can factor in that numerator. And if I scroll down, give ourselves a little bit more space here, I can factor out a 5 from that numerator. So I take the 5 out, I'm left with x minus 6 in the numerator over 2 times x plus 2 times x minus 6. And so hopefully we see that we can indeed cross-cancel away that x minus 6. That's why we had to do all that work up in the numerator, is to distribute, gather like terms, and then refactor, because now we can simplify. We always want to write our answer in simplest form, so our final result is 5 over, and again, no need to FOIL on the bottom, just leave, or distribute on the bottom, we can just leave our answer like